When converting between a percent and a fraction, the key thing to remember is that the word percent means out of 100. So if we have a percent, 8%, and we want to write that as a fraction, we'd start and we'd remember that that symbol means out of 100. So moving from percent notation to fraction notation, we'll be dropping that percent symbol. Whenever we drop the percent symbol, we're going to say out of 100. So 8% is 8 out of 100, 8 over 100. If we reduce that fraction, we have 2 out of 25. That's a pretty straightforward example, percent being out of 100, dropping the symbol. It gets a little bit more involved when our percent is not a whole number. If we have 12.5%, we can still follow that same idea that percent means out of 100. So when we drop the percent symbol, we put it over 100, 12.5 out of 100. But we cannot leave a fraction with a decimal in that as our final form. Although that does reflect the relationship, that's not an appropriate final form for our fraction. So we can use a strategy that we use as when we reduce fractions. Performing the same operation in the top and the bottom of the fraction keeps it equivalent. So instead of doing a reduction, we're going to build up our fraction. And we're going to do this strategically. What we're going to do is we're going to multiply the top and the bottom of our fraction by 10. When we multiply the top by 10, we get 125. When we multiply the bottom by 10, we get 1,000. I want you to notice what happened to the decimal point when we multiplied by 10. We had 12.5 over 100. When we multiplied by 10, notice in essence what happened to the decimal point. Multiplying by 10 shifted our decimal point one place in both numbers. In the denominator, because our decimal was at the end of our digits, we had to add a 0. So we ended up with 125 over 1,000. If we reduce these fractions, we get 1/8. Let's look at one more example. Suppose that we had 6.25%. Starting in the same way, 6.25 over 100. Again, notice that we have a decimal in our fraction. We cannot leave a decimal in our fraction, so we're going to have to adjust our values in the numerator and the denominator to alleviate that problem. What we can do, as we did in the last example, is multiply by 10. But when we multiply by 10, that's going to shift our decimal point one place. Notice we have 2 digits after the decimal, so we're going to have to multiply by 10 a second time to shift that decimal point a second place. So what happens for us, we have that 6.25 over 100. As we multiply by 10, our decimal point moves one place. As we multiply by 10 a second time, our decimal point moves a second time. So we have 625 over 10,000. If we reduce this, we get 1 out of 16. Notice for each digit after the decimal point, we multiply by 10. One digit, 110. Multiplying by 10 moves our decimal point one place. Remember, what you do in the numerator, you do in the denominator.